Okay, so here we have the data inputted into, in my case, column A. May have done the same. And we want to sort it, right? We're trying to find classes. We're trying to find class width. So I need to know the maximum and the minimum data value. So if I want to do that, I can highlight my data. So I'm going to click on that first cell and holding the mouse button, left mouse button down, I'm going to go all the way to the end of my data. Notice it's not in any order other than the order that it was given in. Now up on this top row here, you'll see the tab for data. Click on that and you'll notice a sort feature. You can sort from least to greatest. You can sort from greatest to least. I think it's probably pretty intuitive that A to Z means least to greatest. So if I type, or if not type rather, but if I click on A to Z, Excel is going to take those numbers I gave it and rearrange them from least to greatest. And you'll see much faster than we could ever do. So I'm going to click that button, and now my data is in order from least to greatest. Now while we're at it, let's go ahead and figure out what that class width is going to be. So I'm going to have Excel do that for me. Now, I have 7 classes, and so what I'm going to say is, and notice what I've done. I'm in the C cell here, and I'm saying equals. When you write equals, you're cluing Excel into the fact you're going to give it some computation to do or assign some formula. So the maximum is 132. Actually, we're going to use some parentheses here. The maximum is 132, so that parentheses 132 minus the minimum, 76. Close those parentheses and then divide by, and we had said just a few moments ago that we want 7 classes, so divided by 7. Okay, so again, notice that it starts with an equal sign, and then there's my formula. All right, worked out to be a whole number 8. And what I'm going to do is, remember, I want to be safe here. I want to make sure that my class width is large enough. So I'm going to take, and even though this turned out to be 8, I'm going to round it up to 9, okay? So my class width is 9. Now let's set up our classes. So the first thing I need to do is find my lower limit, and the lower limit of my first class. And so we can go back on Excel and say, oh yeah, we ordered this from least to greatest. 76 is my smallest value. And so my first lower limit is 76. Okay. Now my width is 9. And here's the deal. That width takes me from lower limit to lower limit. Not lower to upper, lower to lower. So 76 plus 9 is going to be 85. And then I just keep adding 9. Okay. 94. Oops. Add 9 again. We have 103. Add 9 again. 112. And then if we add 9 again, that takes us to 121. Whoops. And then add 9 again, and we are at 130. Okay. So those are all my lower limits. I'm now going to do the upper. Well, notice that if my second class starts at 85, then the class just before it is going to have ended at 84. Okay. And then from 85 to 93, from 94 to 102, and then 103 to 111, 111 to 120, 121 to 129, and then 130 to 138. Okay. You might also notice that my upper limits increase by 9 each time as well. So a common mistake that students make is to interpret that class width as the distance from lower to upper, and that's just not true. The class width is the distance from one lower limit to the next lower limit, or from one upper limit to the next upper limit. That's how you use that width. Okay, so I have my classes now. Now it's just a matter of going back into Excel and counting how many values, how many scores fall in each of these classes. So if I come back to Excel here, I'm going to count how many are in each of these ranges. So I would encourage you at this point to go ahead and give the video a pause and do that. So I'll do the first one for you. So 76 to 84, that's my first class. So that takes me from this value, this value, this value, this value. So there are 4 scores in the 76 to 84 range. So the frequency will be 4. And then when we go to 85 to 93, well, let's see, looks like right there, 87 to 93. I don't have an 85 or an 86. So how many scores is that? 1, 2, 3, 4, 5 scores. So in that next class, I have 5. So go ahead and give the video a pause and finish those frequencies out. Okay, so again, I went ahead and finished this up. And these are the frequencies that I got for the remaining classes. Hopefully you got the same. So relative frequency. Keep in mind that we have a total sample size of 30, right? There were 30 scores that we looked at. So my relative frequency I'm going to get by doing this. For my first class, 4 of the 30 values fall between 76 and 84. 5 of the values fall between 85 and 93. 6 are between 94 and 102, and then so on. Now, as I'm writing these, and as we're writing them together, you might be asking yourselves, well, wait a minute, why aren't we reducing? Well, okay, we could reduce these, but we could also write them as a decimal and round. I'm just writing them in this fashion so that you can see that each frequency is being compared as a ratio to the total sample size, okay? All right, cumulative frequency. So again, think of cumulative frequency as a running total. So that first class has 4. Well, the next class has 5. But what we're doing is we're keeping track of everything that came before as well. So if I'm on my second class and I have the 5 data values in that class plus the 4 from the previous class, that's a total of 9. Well, so, oops, I'm going to write this in a slightly different order here. 9 is 4 plus 5. The next class has 6. So 9 plus 6 is 15. Notice that 15 is 4 plus 5 plus 6, right? It's the current frequency plus all those prior. Another way to get those is to look at whatever that current cumulative frequency is and just add the next class frequency. So 15 plus 6, 21. 21 plus 6 is 27. 27 plus 2, 29. And 29 plus 1 is 30. A good indication that I've probably done this correctly is that at the end here, I have 30, same as my sample size. Okay. All right, so that is a frequency distribution. And typically, you know, when I say a frequency distribution, really, we really don't even need everything. Really, the frequency distribution is oftentimes just this much, okay? We went ahead and went a little overkill with the other two, but when we start to build histograms, really you only need these two pieces of information, these two columns, okay? And that is what we're going to do next. So what is a histogram? Well, a histogram is a bar graph that represents the frequency distribution of data with the given properties. Horizontal axis is quantitative and measures data values. The vertical axis represents frequency, and the consecutive bars touch, all right? So it's gonna look a lot like a bar graph, but it's gonna be quantitative. Bar graphs can be qualitative. So I'm kind of being a little loose with my language, but really it's gonna look like a bar graph with touching bars. So what we're gonna do is we're gonna build a histogram for the data using the classes in the previous example. But here's the deal. There is this one little piece that we need to keep in mind. The consecutive bars touch. So what does that mean? Well, let's think about this for a second. Let's say that we have a class, well, let's look at our classes. We had 76 was our first class, 76 to 84. Okay, and so 76 to 84, and then 85 to 93. Well, if I'm setting this up, keep in mind that these values are just X values, 76, 77, 78, 79, 80, 81, 82, 83, 84, and then 85. Guess I should give myself some more room. Oh, this is not a great look here. Let's get rid of that. Actually, we can make this adjustment just here. So right now, right somewhere else out here is going to be the end of this other class, way out here at 93. Well, there's a frequency for this class, 76 to 84, and that's going to become a height. And so we would get some bar. And then there's a frequency for the next class, 85 to 93. But the issue is that there's a gap here, okay? No gaps allowed, okay? That's a problem. So how do we get rid of that problem? How do we change the graph in such a way that we don't have any gaps? And you may be thinking, well, what's the big deal? Well, it's this. When our data is continuous, then we shouldn't have gaps because data values can be all sorts of different values, and we don't want to have those gaps. And this will become an issue. But here's the deal. I have these classes, and I need to choose my bars to touch in such a way that I don't steal any values. What do I mean by that? Well, let's take a look here. I'm going to just kind of put this down here. Food for thought. So when we had the 76, maybe 76 was here, and then we had 84, 85, and then out here we had 93, and we had this gap. Well, we might be wondering, well, why not just make our class go from 76 to, I don't know, how about 85? Well, what if the data value was 85? Right? If I change my classes so that I have 76. Oh, that's not a very good 76. So that my classes go from maybe 76 to 85, and then 85 to 94, and then 94 to, what would that be, 103. Well, what if my data value is 85? Where's it going to go? Right, 85 as a data value would belong to this class and that class. So there's some ambiguity. Would you put it in both classes? Would you toss a coin and just put it in one? Well, the way this is set up, it actually belongs in both, which means it would get double counted, which would be misleading because there's only 185. So this is a problem. So we can't just widen our classes so much that we have the potential of stealing or having shared values with other classes. So the game is this. Let's zoom in between 84 and 85. I have a class that ends at 84, and I have a next class that starts at 85. So what I want to do is pick a value between 84 and 85 and make that my boundary. So this value right here, right in the middle, is 84.5. Now, by choosing 84.5 as my boundary, think about this. They can share this boundary. The two classes can share this boundary, right? I can extend this class just 0.5 to the right, and I can move 85 back down 0.5. They meet in the middle. But is it possible to ever have an actual score of 84.5? No. It is not a possible score. So we have a boundary that has no chance of ever being ambiguous. But now the bars will touch, okay? So watch what happens here. I'm going to take my classes and then I'm going to take my boundaries. So my classes I've already determined, right? 76 to 84, 85 to 93, 94 to 102, 103 to 111, 112 to, where am I here, 120, 121 to 129, and 130 to 138. Now, we already know the frequencies for these classes. For the boundaries, again, what I'm going to do is I'm just going to widen those intervals ever so much as to let them now touch, but not steal any values. So 76, I'm going to change that. Oops, I'm going to get my pen right here. Okay, get that, change that to 75.5. 84, 84.5. So I've widened it, right? I moved left of 76 and to the right from 84, which means my next class, the boundary, can start where the previous boundary or previous class ended. Okay, so there we go. 93.5. 102.5. And so you can see what I'm doing here, right? I'm just, again, creating these boundaries between the classes. And, right, by definition, boundary has to be a shared value. But my boundaries themselves are not values that will ever be attained in a basketball game. All right. I applaud your patience for watching me write these. All right. And of course, we already know the frequencies, right? The frequencies, which I'm gonna have to scroll back up here and look at here, were 4, 5, 6, 6, 6, 2, 1. All right. So we have 4, 5, 6, 6, 6, 2, and 1. All right. Let's take a look here and actually build a histogram now. So what's going to happen is we're going to have a couple axes, okay? And my x-axis is going to start at 75.5, and then notice I just have all my boundaries here. 84.5, 293.5, to 102.5, up to 111.5, and then we have 120.5, $129.5, and at the very end here, 138.5. Now my frequencies range from 1 to 6. So 1, 2, 3, 4, 5, and 6. Okay, so we have 1, we have 6. Of course, this axis is frequency, and these are scores. So my first class has a frequency of 4. So I'm going to come over here to 4, and I'm going to build a rectangle. Okay. My next class, frequency of 5. My next class, a frequency of 6, and a frequency of 6, and a frequency of 6, and then a frequency of 2, and a frequency of 1. Okay, so here are all of my classes with their corresponding frequencies, and I've just made a histogram. All right, so you may wish to kind of pause the video again and maybe go back and just look at how we constructed this. I know we went it was somewhat tedious, I grant you that, but go ahead and let yourself walk through all these steps, and then we will go on. So I'm going to give it a pause. You guys go ahead and do that, and I will meet you right back here. All right, so hopefully you've had some time to digest that. What I would like to tell you next might seem kind of silly, but histograms can be cumbersome. They just can be, to do by hand. The information that we're trying to get out of the histogram is its shape. I'll talk about shape shortly, but essentially, what does the data do? How do the frequencies behave? Do they start low, get higher, get low again? Are they all the same or the same-ish? Are the higher frequencies on the left and the lower frequencies on the right, or vice versa? That's really the information we're trying to glean out of a histogram. A lot of times, we just want to know, is this histogram, do the frequencies start low, go high, and go low? Because if they do, then there's some really convenient analysis that we're allowed to do. So we're not concerned so much of the specifics and the nuts and bolts and the mechanics of getting our hands on this histogram. We just want to know the shape so we can do some meaningful analysis. So fortunately, there are some tools to do this. There are several online. Excel does a histogram, but it doesn't the bars don't touch. I have a problem with that. I'm not going to tell you that the bars need to touch and then give you a tool where they don't. So fortunately, what you can do is come over here to this site called Histogram Creator. And it's on showdoor.org. So if you have this is the URL for that. And what this does is it will make a histogram for us. So it's going to default to, in my case, SAT math scores. I don't know if they all default to this, but obviously that's not the data we're looking at. So what I'm going to start by doing is deleting the data that they've got. So I'm going to hit clear data. Yes, let's clear it. I'm going to retitle this thing and call it Laker scores. And then tell it what my interval size is. So if you remember what we used a width of 9. Our minimum value of the y-axis, so our frequencies. Remember our frequencies went from 1 to 6, so I'm going to start at 0. It's typically where you want to start on the y-axis. And then the maximum frequency was 6. So if you want to give a little bit of vertical space so that your highest bars don't necessarily take up the entire vertical space, I might make my maximum value on my y-axis 8, let's say. 7 if you want, 9. Just give it a little bit of space. All right, so I'm going to update that. Of course, it's telling me, hey, you need to have some data. So let's go over here to Excel. I'm going to highlight this data, and then I am going to copy it. You can copy by right-clicking and hitting copy. And then I'm going to come over here to this box, and I'm going to right-click and paste it. Okay? Once we've done that, we're going to go ahead and adjust everything to do what we need it to do. All right, so if you look down here at the X minimum, right, we want that to be our boundary. So I'm going to make that 75.5. And once I've done that, here we go. We have now got Laker scores, frequencies. And you could also have this show the frequency table for us, right? And here it is. And so this is a great tool to use. And for me, honestly, I want students to be able to construct a histogram by hand, because that's often where you learn just the nuts and bolts of it and have an idea of where things are coming from. But at the end of the day, when we actually move away to future topics and you need to get your hands on a histogram, please, by all means, use technology. And like I said, I really like this site. It's very simple to use. It does exactly what we need it to do. All right, so let's keep going here. So here's a question. What happens when we change the classes? You know, when you look at basketball scores, it seems more natural to say, okay, a team scored in the 70s, the 80s, the 90s, as opposed to saying something like, well, what if they scored between 76 and 84? That seems just not like a natural denomination of basketball scores. So let's do this again, and let's look at what happens when we use these classes. And so we're going to go, notice here, this is also going to give us maybe a different number of classes, maybe not. Let's just see what happens. So my classes are now going to be 70 to 79. In other words, they scored in the 70s, 80 to 89, 90 to 99, I think think you guys get the gist here. 110 to 119, 120 to 129, and 130 to 139. Now, while we're at it, let's establish the boundaries. Because again, we need these bars to touch. So we're going to widen these classes so that they share a boundary. So this first class, instead of starting at 70, we're going to start it down here at 69.5, and we're going to end it at 79.5. Again, not possible scores in a basketball game, which is good. We want 79.5 to be a boundary shared with the next class. And sure enough, it is. And then 89.5 to 99.5 and 99.5 to 109.5. And we're just going to keep this going. Assuming I can write correctly, which sometimes is a big and frankly valid concern. Let's see, here we go. All right, so we got our classes, we've got our boundaries. Now let's look at the frequency. All right, so first class here. So let's go back to that Excel sheet that we have, and I'm actually gonna just do this. So scores in the 70s. Look at this, I see 1, 2 scores in the 70s. So that frequency is 2. And then let's see, the 80s, we have 1, 2, 3, 4, 5 in the 80s. And 1, 2, 3, 4, 5, 6 in the 90s. So we've got 5 scores in the 80s, 6 scores in the 90s. And then 1, 2, 3, 4, 5, 6, 7, 8 in my next class. And then the 1-teens, or the 110s to 120s, let's say. 1, 2, 3, 4, 5. Got 5. And then these last 2, let's see, 120s, we're going to have 3 and 1 in the 130s. All right, so 3 in the 120s and 1 in the 130s. All right, let's go ahead and draw our histogram. So I've got my vertical axis, which is frequency. I've got my horizontal axis. Whoops. Gonna extend this out a little more here. Well, you know what? Let's try that again. Actually, I'm going to cheat a little bit. Well, sorry guys. All right, so freehand this. All right, so again, my first boundary is 69.5. And then 79.5. 89.5, 99.5, 109.5, 119.5, 129.5, and 139.5. And then our frequencies, right, from 1 to 8. So 1, 2, 3, 4, 5, 6, 7, 8. One more. That's 8. That's 1. So my first class frequency is 2. And then 5, 3, 4, 5. So my next class has a frequency of 5. My next class, a frequency of 6. And a frequency of 8. Then a frequency of 5. And then a frequency of 3. So there's 3 over here, just kind of eyeballing this. And then a frequency of 1. Well, you can give those a little scribble. So we've got this shape. So is that all that different from the previous histogram? Well, the previous histogram looked like this. Yeah, there are some differences. I mean, we have some, it's pretty uniform in here. But it still starts low, gets higher, and goes low. It starts low, gets higher, and goes low. Okay? So notice, keep in mind, you know, it's easy to get stuck in all the mechanics, but we want the shape. And my point here is that even though we messed with the lower class limits a little bit, and therefore the upper class limits, we still got the same shape. It gave us the same information. So we will inform our analysis later on in the same way. Okay? So that's the big lesson here. Slight changes in classes, even changes in number of classes, will still give us similar shape. All right. Speaking of shape, there are really 4 primary distribution shapes that we'll look at, and we'll come in, we'll familiarize ourselves with. This is not all of them by any means, but these are the common ones that I'm going to be hitting on. The first is normal or bell-shaped. In this case, the graph is going to go up and then down. So the 2 histograms that we just did, right, they did just that. They went up and they came down. Uniform, and we could fit, you know, I could fit a histogram in here. The curve is just sketching the shape. The histogram would do something like this. Okay. Now uniform is going to be just that. Something that's uniform. Now, do you think it would be perfectly uniform? No. But basically uniform. Skewed left is going to look like this. The highest frequencies will be on the left. And then skewed right, in this case, the tail will be on the right. So the highest frequencies are on the left, and then this thing just tapers off. The skewed right does something like that. Okay? So those are the 4 major shapes. There are others. Bimodal, that's one that comes to mind. But really, we'll be focused on these. All right? So I've given you a lot to think about with these histograms. I would really encourage you to spend some time rehashing what we did together here in lecture, and then try some on your own. In fact, there is one right here for you to try. I would encourage you to try it now before you move on, kind of sum everything up. So once again, I'm going to pause this, and I'm going to go put this data into my online histogram builder, but it would be worth it for you to do it by hand and then check it with what I give you. So go ahead and give yourself a chance to do that, and I'll be back with you shortly. All right, so here's what I did. I went ahead and put all of my data into Excel. I sorted it, and that gave me a minimum, a maximum. I used that formula, max minus min divided by 7, to find the class width, which came out to be about 8.5-ish, 8.57 change. So I'm rounding that to 9. So here's 9. That's my interval size. Again, I'm starting at 0. My maximum value is about 16. And then notice my minimum X value, I'm setting at 35.5. Why 35.5 and not the minimum? Well, yet again, that is my boundary. I want to start at my lowest boundary, which is going to be 0.5 less than my lowest value. And so from 35.5, we go up by 9s and we get this wonderful shape. So hopefully yours looks something like that as well. And again, histograms come with practice. You should be able to do them by hand. You should also be able to glean the relevant information by using technology. So if you can be able to do both, you will be in great shape. And that is all. I will look forward to seeing you as we move on. Next section, we're going to look at some other types of graphs. So until then.